For my tutorial, and actually there will be kind of two tutorials that we'll go through here. We're going to be going through co-simulation with RecurDyn and Particleworks, and in particular co-simulation that includes flexible bodies. And so this is incorporating the full flex in RecurDyn, all of the nonlinear flexible bodies that are included in that. So one of the difficulties in going through this tutorial and setting up this tutorial is that for the majority of you, you won't have access to Particleworks right now. If Particleworks is something that you'd like to try out, we can get you a trial license. We can work with you on that, and if there's something that you're curious if it'll work with your models, we'd be happy to help you out, help you get started, and help you work through some test cases to figure out if this is something that's practical for you. I'm going to be showing the process, what the general process looks like, and I'm actually going to keep my screen up the entire time, and I'm going to be talking through the tutorial. I did share with you a tutorial that you can walk through on your own, but you will need Particleworks to get through the entire thing. I would suggest following along with the things that are involved in RecurDyn, just to kind of get a feel for how it works. It's there's nothing too complex on the RecurDyn side of things as far as new things to learn on RecurDyn. There's a whole new software in Particleworks that can be a bit of getting used to, that we can help you out with. But on the RecurDyn side of things, it's not too difficult, but it would be helpful if you follow along as much as possible. All right. One of the things that I guess the first thing that you'll need to do if you're following along is that this external SPI section probably should not show up for you by default. And that is why I included in the files that were sent this morning a particleworks.xml file. And I will actually bring up real quick the instructions for where to put that. So that particleworks.xml file has to be placed in a particular location in your RecurDyn install directory. And get to that real quick. So it's just this first few lines here. So if you had Particleworks installed, you would copy the particleworks.xml from the install path of Particleworks, but I included that file for you. And so you'll copy that from wherever you saved those files, and then paste it into the RecurDyn install path. And from there, it's bin, solver, cosim, std particle interface, and then that's where you would paste that into. So it's a bit of a path to get there, but it's not too difficult. And I'll briefly show where that is. And so from RecurDyn B9R3 install path, I'm going into bin, and it's solver, cosim, std particle interface. And that's where I placed that Particleworks XML file. So one of the most common ways of getting errors is just not being careful about where files are saved and things with this co-simulation. So there are some aspects that need to be done somewhat precisely, and this is one of them that something that needs to be saved to a certain location. But I will feel free to ask questions if you need to, but I think that I will move on. The first few things are not things that you'll necessarily be needing to work along with me on. And if you need to find this again, I included in the files that I shared with you a tutorial that's in a PDF format, and this is what I'm reading right now. And so this is one of the first steps from that tutorial that was in the files that I shared with you. And so you just go to this page that has the copy configuration XML, and that will have the directory that you need to copy that to. Okay. Feel free to ask any questions if you need direction on that. But if you do copy that to that location, you may need to restart RecurDyn, but there should be this external SPI tab up at the top, and this has the Particleworks interface, the functions that are available for the Particleworks interface on that tab. There is the older communicator tab, which you may have up there as well, but so that does have a Particleworks interface. That is a little bit older, and you can't do the flexible body co-simulation, including the flexible bodies, with this older interface. So it's the newer external SPI interface is the one that you'll want to be using. Okay, so just to briefly describe this file that I shared. So go ahead and open this mixer start file, this RecurDyn file that I shared with you. And in this mixer start file, what we're looking at is this is some type of mixer. So this body here will be in a tank of, in my simulation it was just water, but a tank of some fluid, and it will rotate and mix up that fluid. And so it's a pretty simple simulation, and not something that takes a long time to run, not a lot of elements. I could have, I definitely think that this mesh needs to be worked on a little bit. There's some, there were a lot of features on the geometry that I imported that needed to be defeatured before, really needed to be defeatured before meshing, but I, for simplicity's sake and for the sake of this example, this mesh seemed like it would work fine, and it does run fine. I do think it needs a bit of work if you're actually looking for results from this, but it'll work for this example. All right, so all this does is it rotates about a revolute joint, and nothing too complex. You can still include everything that you'd normally include in a RecurDyn model when you're running co-simulation. You can still have contact, you can still have multiple bodies. I just have a simple thing here, but you can have multiple bodies coming in contact. You can have, you can include toolkits. I actually have an example over here. This is just a chain toolkit, and it's fairly simple to, when you're exporting these bodies into Particleworks, it's one click to do the entire chain. And so this is just another example that I'm working on with the chain toolkit. And so we're going to go through the process of how you run this co-simulation for this mixer model. But I think it's useful to just kind of see where we're heading with this. And so I actually ran the simulation last night. I didn't use a lot of particles. You can see that these are fairly large particles relative to the size of the this blade mixer here. But it seemed like a good decision to make things run quickly. And this only took 30 minutes, about 30 minutes, a little bit less than 30 minutes actually to run on my computer. And so this is using a GPU to do the particle calculations. But it does run fairly quickly with this number of particles. You can certainly, once you're getting up, I think this is about 30,000 particles, and certainly once you're getting up to about 1 million particles, you're looking at probably several hours to a day to run something like that. But with this number of this number of particles, you're only looking at about 30 minutes to run this simulation. All right, so I'm just going to briefly go through the results, kind of some post-processing to start out to see where we're heading with this. So this is just a simple model where all that mixer's doing is rotating about a single axis, and there's some type of tank that's holding this fluid in place. But a fairly simple model there. That's how it looks with just the standard viewing options. And we're going to go through and look at some different viewing options to see how we can get some relevant information from this. And so the first thing that we're going to do is, just like a normal full flex model, you can go into this flexible tab and change the contour. And so I'm going to go ahead and enable the contour view. And did I not save it? And I didn't save that part of it, so you won't be able to see the contour view, but it's you'll still be able to see the animation. You can go into the contour view and change things there. You can also change the particle contour so that you're looking at so go ahead and actually do something that we talked about yesterday and change this clip option. You can clip particles, and so I had been messing around with this earlier, so I'm going to turn that off and we'll come back to it. But so just the standard view right there, and then you can go into this and change the particle contour. And so I'm going to go ahead and up that. So now we're looking at a velocity profile of these particles in the simulation. And a lot of times it's useful when you're looking at these particle simulations to go into this animation view, and instead of looking at it like that, add some transparency to the particles so that you can see into the fluid a little bit more. And so adding in some transparency, you can see things a little bit more clearly, see what and this is just a velocity magnitude in those particles. And since this is a mixer, I thought one of the things that might be interesting to look at, one of the outputs that you might be interested in is this clip particles. And so what the clip particles that do is you can set certain ranges where the particles won't be viewed anymore. So if you set this and it's updating at the moment. And so what I did here is I actually set this so that there would be a maximum velocity to those particles. And so now when I run the simulation, it's actually only showing the particles that are under a certain velocity. So one of the things you might be interested in is certain areas that aren't being accelerated, are at a low velocity. So you can clip the particles in that way. And so those are just a few of the different ways of viewing everything when you're when you do receive your results. And so it's somewhat intuitive where the regions are that the particles aren't accelerated sort of towards the edges, and in the middle there's also a little bit of a dead spot in this simulation. And so in addition to those ways of viewing things, you also have all the standard outputs that you'd normally get from RecurDyn. So you can get things like input and output torques, and you can get all your reaction forces and different reactions that can include the simulation as well. One more thing that I did want to show.
Zach?
Yes.
A quick question. So while you're showing us the results of this co-simulation with the particles, as I understand, since we do not have access to this software, we are just watching, but we are not doing it, right?
Correct.
Okay.
Correct. You don't.
All right.
Yeah. As of right now, you're just watching. As we start, we'll get started in a little bit going through the process, and you'll be able to do the things that, at least in the RecurDyn side of things, but even the RecurDyn side of things is fairly easy to set up.
Okay.
And this, I'm looking at this top view just so you can see that this is I set the material properties so that it would be quite flexible, and so you actually have a fair amount of flex in this body during the simulation as a result of the interaction between it and the particles. And so this is just to show that you can include things that can deform quite a bit, and large deflections, and it's able to handle that during the co-simulation between RecurDyn and Particleworks. All right. So now we'll go through a bit of the process of how to actually set this up and run this simulation. This is a fairly simple thing that shouldn't take too long to go through, and then we'll also go through a second model. And that second model was the one that I included the tutorial for. So this first one is just the RecurDyn model, and I'll be just talking through that one. But the second one actually has a step-by-step walkthrough. All right. So one of the I guess most important things to consider that I guess is an important way that some people run into errors when they're starting out with this co-simulation is that the files do need to be saved to certain locations in order for the co-simulation to work. So you do need to make sure that you're working in the same directory for both your Particleworks model and your RecurDyn model. And so the way that I like to do that is actually I like to start in Particleworks. So as of right now, you still won't be able to follow along, but we'll get back to RecurDyn quite quickly. And so I like to start out in Particleworks, and Normally you'd start with a new model, but I have something already running because you won't be able to follow along with the Particleworks side of things, so I wanted to speed things up a little bit. So I start with a new Particleworks model, and in this case, all I have in this Particleworks model is this tank and this fluid. This fluid's filled to a certain location. The fill is fairly easy to do in Particleworks. I like to use what's called the wizard in Particleworks, and the wizard will kind of walk you through the normal steps of how to run things. And in this section is where you can import geometry and also add this fill, and so it'll just fill the fluid to a certain certain defined location. If you have something like a tank or some type of housing that doesn't have any holes in it, then it'll fill that for you. Go ahead and leave that for a second. So all you'd want to do is start that, and then as you start it, you'll want to save it to a certain wherever you want that file to be, but whatever directory you want that to be in. And so I've created this in just a file called test10, and then I have this mixer1 model here. And so this is the Particleworks folder that's created by default, and there's a few things that are included in that: the models, Particleworks project, scene, and I'm going to go into the scene here. And the scene of Particleworks is where you'll want to save your RecurDyn model to. And so that's what I've done in this case. I've saved that. In this case, the mixer start, I actually have two RecurDyn models. You can't have multiple RecurDyn models associated with it, but I have this mixer start model here, and that's the RecurDyn model that I'm going to be working from to run this co-simulation.
So once again, where would you? We should take which file? Which RecurDyn file?
It's just the RDYN file.
Yes.
And
okay.
so, and really, it's all you'd normally do is you'd open up your RecurDyn file again,
Yes.
and you'd click Save As, and then you'd locate your so going into what I call the mixer, then the scene folder of Particleworks, and then you just save your RecurDyn file in that location. But this
where do we have this mixer folder that you're talking about? Because I'm
right. The mixer folder is something that would be created with Particleworks, and so that's why it's a little bit difficult to follow along with this tutorial, because you would need Particleworks to go through the entire thing.
Okay.
So the idea is when you save your Particleworks model, it will automatically create this subfolder called scene. And then that's where you place a copy of your RecurDyn model file or RDYN file. So it'll happen naturally. I mean, you're starting out with your RecurDyn model, and then you'll start with your Particleworks model, and then as soon as you save the Particleworks model, in this co-simulation folder, then the scene subfolder will be created for you.
Okay, but for right now, since we do not have this, we just keep our RecurDyn model where it is.
Correct.
Correct.
Okay.
Yeah.
Okay.
So you'll only be working with the RecurDyn model, but if you had Particleworks, then you'd save it into the scene folder.
Okay. All right.
All right. So now I have I'm going to go back to the starting folder, the starting file. So this should be the file that you have available. So this is this mixer start RecurDyn model. And so if you open that up, then there's a few things that Particleworks needs. Particleworks needs to know which geometry that you're interested in coming in contact with the fluid, and for full flex models, for full flex bodies, you will need to define a patch set in order to define that body. And so rather than including the rather than sending the information about the body itself, it'll send the information about the patch set. And so the way that we'll go ahead and do that, we will define the patch set right now. So this is pretty much ready to go as far as the RecurDyn model is concerned. I already have the revolute join. I already have the motion defined. And so I'll just double click on it to enter this edit mode, and I'll go into set and patch set. And I'm going to go ahead and add everything that's on this body. You can define just you can, for example, just define part of it, and if that's the only part that comes in contact with the fluid, then you can do that. But for this example, I'm going to select the entire thing, just drag over the entire thing and say finish operation. And then that created this this patch set that's over the entire body there. So that's all I need to do here. I'll go ahead and press exit. So now the next thing that I will need to do here is define a wall. And a wall in Particleworks, in co-simulation with Particleworks, defines the interaction between RecurDyn and Particleworks. And let me see if I... And so the wall is kind of the intermediate body in between these two programs. So RecurDyn will send information about the position of that wall, the velocity acceleration of that wall, to Particleworks, and then Particleworks will then go ahead and define all of the interactions between the particles and that wall, and then it'll send back information about the reaction forces from those particles back to RecurDyn, and then RecurDyn's able to take those reaction forces and define accelerations and all the rest of the information about the dynamic model from that. And so it's able to efficiently keep those jobs a little bit separate, and yeah, that's how that is handled. So in order to run co-simulation, you have to define a wall. You can have any number of walls that you want in a model. If you have something like a chain or a belt, you can also go into the wall and define that entire chain with a single click, and it will keep everything together with a single click. But in this case, we only have one body that we're interested in, so I'll go ahead and click wall. And so there's multiple creation methods here. In this case, we are interested in the patch set. If you're interested in connecting to a chain or a belt or something, then you'd be in the click on the assembly, and it would take that belt or that chain as a single assembly. But in this case, we are interested in doing the surface patch set. And there's only one patch set in the model, and that was defined previously, and it's automatically highlighting when I go over it, so I'll click on that. And you'll notice in the database window that a wall was created, just called wall 1. And so you can you rename it if you'd like, or...
do we have this, or because I do not see these icons even in my screen?
Did you go through the process of including the Particleworks.xml file?
I loaded this, like I saved this Particleworks.xml file in that folder that you pointed out, but how do I
still don't have it?
No.
Have you since then closed RecurDyn and opened it back up again?
Yes.
Okay. All right, so this is the location that you saved the Particleworks.xml file to, the RecurDyn B9R3 bin solver.
Yes, right, exactly.
COSIM STD particle interface.
Yes. Just a moment, let me go there again.
Let's see.
Exactly. The MS.
Let me check on something real quick.
So Mark, did you make sure that that XML file was inside the standard particle interface folder?
Just okay, I'm going there. So I'm going to bin, solver, co-simulation. So yes, yes, it is right there. COSIM, and then the standard particle interface, XML.
Can you go into the start menu and find your RecurDyn B9R3 and then open up this toolkit configuration tool?
Just a second, hold on. No. Toolkit configuration tool, yes. I have checked everything.
Everything's checked, and you see the standard particle under that?
Yes, standard particle checked. Checked in both columns.
Okay. Do you have V9R2 installed on that computer as well?
No, I do not.
You don't. Okay. You could test if you save that to the same location in V9R2. You could test if it opened up in that one.
No, I don't know.
I don't know if I'm going to be able to debug that at this time. You may have to follow along with.
Okay. All right.
Well, maybe. Yeah, and you're using the master key trial license, Mark?
Yes. Yes.
Okay. So could you share your screen with us, just showing the folder or the XML file where you place the XML file? Could you share your screen and let us look at that folder?
Okay, hold on. How do I share my screen?
So there's like a little, the third icon down in the GoToMeeting panel says share your screen, or
just a second, I'm going there.
Or the second icon. I don't know if you have the GoToMeeting panel expanded or contracted, but the middle, if you have it expanded, the middle thing says share your screen.
Just a second, because I have so much stuff open.
I mean, I may need to make you the presenter, but I know if I share my screen, it will make me the presenter automatically. But.
Screen. No. Gosh, I just. Your screen sharing.
All right, well, I'll tell you what, I'll make you a presenter.
This is okay.
I'll make you the presenter and see if that helps you be able to share your screen.
Okay. Do you see my screen?
I see a RecurDyn
yes, okay.
window. So can you bring up that folder?
Yes, right here.
And solver. Well, it looks like the right location.
Yes.
Oh, you have external SPI. So go ahead and close the folder.
Okay.
And then look up on the tabs in the RecurDyn interface, and like third from last is external SPI. Go up to the tab, go straight up.
Okay.
Click on external SPI.
Yes.
Those are the icons that
I'm
working with. Okay.
Okay. Got it.
Yeah. So you're in good shape.
Okay. Okay. Thank you. Thank you. Sorry. Thank you.
All right. Glad we got that figured out. All right. So we had just created a wall in RecurDyn, and so if you still need to do that, Mark, just press the wall, and then click on the patch that was just created, and it creates this wall here. And so this wall can be renamed if you want. I'm just gonna leave it as wall 1, but so that defines that interface between RecurDyn and Particleworks. So anything that's not defined as a wall in RecurDyn will not have contact with Fluid when you start the co-simulation. And so if you have multiple bodies, you'll want to make sure that everything that does come in contact with the fluid is defined as a wall. So after that, you'll want to press this export button. And what that export button does is it exports that wall that was just created, and it saves. Well, it saves two things. There will be a wall file, and then there will also be the source geometry for that wall file. And so it'll save both of those things. So I'll go ahead and click export. And this as well, you'll want to save to the same location that that you saved the RecurDyn file to. And so that will be saved into the scene folder of Particleworks. I won't worry. And so that is actually all that you need to do in RecurDyn to get the co-simulation running, is just that simple aspect, and then later we'll come back to actually run the simulation, but the remainder of this will actually be done in Particleworks.
Hey Zach, could you make a comment about, I guess on some of these tutorials we actually have the containing vessel inside of the RecurDyn model, and then define that as a wall. But in this case, you created the containing vessel for the particles in Particleworks, or is that in this model
Right.
and I can't see it?
Yes, that can be done either way. So there are bodies that, for example, if you have multiple bodies in a RecurDyn model, maybe you actually have the container in your RecurDyn model for the mixer. In that case, you can just select that container as well and export that as a wall, and so you'd end up having a container that's a rigid body, and then also this full flex mixer blade here. In this example that I'm running right now, I just happened to have the container in Particleworks rather than having the container in RecurDyn, but you can do it either way. It's just the bodies that are that you're including in your multi-body dynamics model are the ones that you'll definitely need to include in RecurDyn, and then sometimes there are things like containers that you don't necessarily need to have in RecurDyn, but could be more convenient to have that in RecurDyn. And
okay,
so
thanks.
in the next example that we go through, the container actually is in RecurDyn, but in this one it happens to not be. Okay. All right, so I've already defined multiple things in Particleworks. The only thing that I'm going to worry about at the moment is go ahead and click this Start Wizard, and then I'm going to open, I'm in this Model section, Open, and I'm going to find this Particleworks wall file that I had saved previously. Go ahead and click Open there. And I don't think that that's showing up for you. Is that?
It's not. We just black box. I mean, black screen.
Okay, just a second. Sometimes with GoToMeeting, there's things that it doesn't like to see, but is that showing up now?
Yes.
Okay. So now I have this this body in here that was imported, and this simulation. At this point is when you do all the things that set all of your fluid properties. You do things like define interactions between the fluid and the walls, what type of viscosity you have in your simulation in the fluid, and you'd also define some simulation parameters. In Particleworks in particular, the time step that you select is an important feature that can take some time getting used to, but so you do things like select your time step, do some things to change the pressure model, the viscosity model that's in this simulation, do all the CFD type work that you'd normally include in the simulation. And then from that point, once your fluid properties are all set, you have to run through the pre-processing in Particleworks, and in order to do that, you go ahead and click this Execute, and go ahead and select this pre-process and simulation. In this case, I'm using a Titan XP GPU that for my setup, that will run much faster than if I use the CPU cores. You can change between double and single precision. And I'm going to actually close without running the simulation. I don't need this to run in Particleworks. I just need to run through some pre-processing so that all the particles are defined and there's all the interactions are defined. I don't need to actually run the simulation. So I'm going to click this close without running simulation. I have some backups there. So here it runs through the pre-processing and then stops at that point. And at this point, things are ready to run, and you can, all you do is go into this, run the simulation in RecurDyn dynamic kinematic, change the simulation parameters as you want to, and then all you do is click the simulate there. And this simulation, it takes about 30 minutes to run. I had already run it previously, so I can skip that for now, but if you want to make changes to your model, you don't need to go through that entire process again. You can, as long as you're not making changes to the bodies, you can make changes to, for example, the revolute joint. You can change the speed of the mixer. You can change things like the material properties to make the blade more flexible and rerun it without going through the entire process again. But if you do make changes to the wall itself, then you'll need to go through the process of exporting again. But yeah, so that's the basics of how that works. I'm going to go ahead and go through a second example. The second example is something, is there a question?
Yes, Zach, a quick one. This external SPI tab, is this tab specifically only for the Particleworks, or for basically for co-simulation with Particleworks, or it is a RecurDyn tab that is being used if we do co-simulation with any other software package?
The external SPI is the SPI stands for the standard particle interface.
Okay.
So I believe it's a similar tab, but slightly different icons if you're doing co-simulation with EDEM.
With anything else, okay. I see.
But yeah, so it's EDEM or Particleworks. So it's just the particle interface, standard particle interface. So,
okay.
Yeah.
All right. I got it. Okay. Thank you.
Okay. All right. So for the second example is actually a step-by-step tutorial that was that I shared with you. You can feel free to work through those steps in the tutorial, but because we'll have those problems with for the majority of you won't have Particleworks. I did go ahead and just decide to go through this tutorial step by step on my screen. So feel free to stop me at any point to ask questions. I'm going to kind of walk through, talk about each step, and talk about how you'd set things up, and give you a little bit of a background there. But I will be going through the steps in that tutorial. And if you want to have the tutorial up, you can do that as well. I'm going to have the tutorial, and I do tend to do things a little bit differently as far as file management. The way that I describe the file management is a slightly different. They go ahead and copy the files and paste them rather than opening up. I guess the way that I do things, I switch between Particleworks and RecurDyn a little bit more often, and the way that the tutorial is set up, it doesn't switch between Particleworks and RecurDyn as often, but it does involve some copying and pasting of files.
And if the parts are plugged in a certain way?
All right, so all right. So I did include the RecurDyn model, the starting model for this tutorial, and the files that I shared with you. I'll go ahead and just open that up. So go ahead and browse, and it's the Styler Flex model cloth start. And so this model is fairly interesting. It's supposed to represent basically a shirt or a shirt that's in the styler that has some fluid that's kind of spraying at it, and it ends up cleaning. I believe it's designed to clean it a little bit, or either that or shake dust off and remove some wrinkles with steam. And so it's just kind of a interesting example. How does that steam interact with the cloth of the shirt? But in order to do this, we'll do kind of the similar process that I did in the previous example. And so the first thing that you would typically do is you would go through that process of making sure that you had saved the XML file in a certain location, and you also need to confirm that RecurDyn knows the path for the Particleworks solver. The instructions to do that are in the tutorial, but that's something that I've done previously, so I'm not going to worry about that at this time. But just like I said previously, it's this process of making sure that Particleworks and RecurDyn both know where the respective solvers are located, and so that they can communicate with one another. All right, and so now the next thing that we need to do is define the patch set that's on this this piece of cloth, this shirt or something. And so in order to do that, I'm going to enter the edit mode of the cloth FE body, and then there's also an outer tank. And so need to go into, I'll right click on it, go into edit. And similar to what I did with the previous mesh, in the previous mesh I was working with solid elements, so this is, these are just shell elements, but the process is exactly the same. So I'm going to go into the patch set, go ahead and click add and remove. Select all of the patches just by dragging over it, and then right click and finish operation. Okay, so now I have this this new patch set that goes over the entire body there. So now I'm going to click exit. And so now what we want to do is create walls for both the cloth and the outer tank. And so I'm going to go into this external SBI tab, And in the window here, go ahead and select the wall. And here I have as a default the surface patch set. I want to change that to body and select this outer tank. And so that created one of the walls that I need. I need a second wall though for the FE body. And so I'll click on the wall again. Instead of selecting the body, I'll select the surface patch set. Now I can't access that just by doing that, so I right click on it and select list. I'll go ahead and show that again. So I right click, select list is an easy way to get to things that are difficult to select because they're behind other bodies in your working window. And so I know what I need here. It's this cloth FE set patch 1. So I click that, press OK. And so now I have these 2 walls that I need for the co-simulation with RecurDyn, or between RecurDyn and Particleworks. And so these aren't great names, so I'll go ahead and redefine them. As you get more and more bodies, it becomes more and more important to name them correctly. So I'll change that first one to wall outer tank, and the second one to wall cloth FE. All right, so I have 2 walls that are defined for this simulation, and so now I can go ahead and click the export button. And here I'm going to go ahead and I'll leave that there. I have well, I'll change it. All right, so you'll save that really to wherever you want. You're going to be copying and pasting this later if you're actually going through the entire tutorial. You actually don't necessarily need to save this if you don't want to, since you won't be able to import that into Particleworks at this time. But in order to show how it's done, so I export that wherever you want to at this point and click Save. And I'll go ahead and show real quick. So at whatever location that you export that wall file to, there's 2 things that are created. There's this, you had the option to rename it, but rd_pw.wall, and also this wall geometries folder. And inside the wall geometries folder is the 2 geometries there. But ultimately, even though that's there, ultimately what you're going to be working with in Particleworks is just this .wall file. So those are the 2 things that are created when you click export. And so now at this point, we're ready to start working in Particleworks. So I'm going to go ahead and click Save on my model. And I'm ready to, yeah, I'm ready to close and enter Particleworks. So the way that I have this set up, I would need to close it because I'm going to be copying that RecurDyn model file into a new location in order to run co-simulation with Particleworks. So I do need to close that. And the first thing that we're going to do is open up a new file in Particleworks. So I'm going to do File, New Project. And here you define wherever your project location is. I have something that's somewhat convenient already set up there, so I'll have that folder, and then you name it whatever you want. So I'm just going to call this styler. Click finish, and at this point, Particleworks has created this new folder called styler, and inside that folder is already all of this information already included in it. And so what I want to do is I want to navigate to this styler folder that was just created and go into the scene, and I actually want to copy the RecurDyn model file, the wall geometries folder, and the wall file all into this location. And doing so will make it easier to, it's important for Particleworks to be able to communicate with RecurDyn, but it knows where all these files are. Now this is something that I like to start up Particleworks first and create this folder, and then go ahead and start from the beginning working with the RecurDyn model file that's in that scene folder. Doing so makes it so that you don't have to copy and paste the folders into this new location, or the files into this new location, but it does mean you go back and forth one more time between Particleworks and RecurDyn. So I'll go ahead and get to my location where I saved those folders. And so I need this RecurDyn Particleworks .wall file and the wall geometries. Copy and paste. And then I also need this styler flex model cloth file that I was working with. And so I copy and paste that as well, all into the scene folder that's in Particleworks. All right, so that's ready to go now. That all those folders are saved, files are saved to the correct location. So now those things are ready to go, and I'm ready to work with that in Particleworks. And so what I want to do here is, so I've created this this new project. I want to open the scene, and so this scene is your working window in Particleworks, and that's where you're able to view all of the information about what you have in your model. So I open the scene, and so now I'm ready to import the geometry into that I just created in RecurDyn, ready to import that into Particleworks. And so the way that I would do that, I like to use the wizard in Particleworks. It gives you a step-by-step process of how to do things. And the first thing that you'll want to do is open up and the model open. That's how you import geometry in Particleworks. And so then you'll navigate to your scene folder, and what you want to import is just this rd_wall file, and click open. And so you'll notice that two files were imported. So I only imported the wall, but it knows that there's two things contained in that single folder, and so we have two bodies here that are ready to be worked with. And so this is kind of small on my screen. There's just like RecurDyn or other tools, there's convenient ways of working with things in Particleworks. So you use this button right here to do fit. And I'll go ahead and change the orientation so that I'm looking in the Z direction there. All right, so now we have two bodies, but there's only one that we can actually see. So I'm going to go ahead and click on this outer tank and double click on it. And I can change some appearance settings. And so one of the things is this alpha feature that sets the transparency. And so I set that to something, so it's a value between 0 and 1. Set that something to more like 0.2. And now you have, you're able to see that a little bit more. I'm going to all right. So I just changed some things to make it a little bit easier to work with. So there's default camera options, and I changed it from a turntable to a trackball, which the trackball is what your more standard, easier way of working with things. But sometimes it's more convenient to work with the turntable, so sometimes I have it set at that. All right, so coming back to the tank, you can see everything's everything's in there. One is somewhat transparent, the other is not. And so we have both of these bodies in here. So the next thing that we'll want to do here is you'll notice this, if I zoom out, there's this large box that's contained in this scene. And what that box is defining is it's defining what's referred to in Particleworks as the domain. So it's defines the boundaries of your simulation. So if you have any fluid that leaves this box, it will just be removed from the simulation and no longer be taken into account. And typically, what you'll do is you'll define your domain to be just slightly larger than what you expect to happen in Particleworks. And so I'm going to go ahead and double click on the domain. And I'm going to manually set the domain according to the description that's in the tutorial. And so I'll set that to 0.3, 1.96, 0.3, negative 0.3, 0.55, negative 0.3. Okay, so go ahead and click fit again, and you can see that the domain now is just around that box. Something that I like to do quite often is just click on this adjust domain button and set a relative value. And doing that, you'll say something like 10, and that means that your domain will be 10% larger than your largest body that's in this model. So have a 10% gap around that outer tank. That's one thing that, I guess, an easy way to do that same action without inputting the values manually. All right, so now we have these bodies in here, but as of right now, we don't have any fluid. And so there are, in this example, this will be a little bit repetitive, but we're going to define 6 inflows. So 6 regions where fluid is being sprayed at this body. And the way that we do that, we're still in this wizard option here. And so now there's the option to add inflows. And so I'm going to there we go. So I'm going to go ahead and select this option, and I'm going to click a total of 6 times, so there's now 6 of them. And I am going to go into each one and edit those so that they're in the right location. And so for each of these, I'll need to change the width and height to be 0.1. So you can see that before that was a 5-meter circle, and now it's a 0.1 meter circle. And I'll also need to change those so that they're in the correct location. So I'll try to do that somewhat quickly, but so 0.2, negative 90, 15. Oh. All right, so then you can see when I did that, that you have this inflow that's now towards the top of the screen, and it's pointing in at that body. And so I'm going to go through that same process of defining that location for each of those. So it'll be a little bit repetitive, and I don't know if there's much to say while I'm doing this part.
So while Zach's working away here, maybe I can comment that this, styler device actually is a real thing, and I think it sells for like $2,000. And kind of reading some information about it, I guess they felt like the market for it wasn't necessarily in people's homes, but more like office spaces where I guess people might want to kind of refresh some of their clothes before a meeting or some crazy thing. I don't know. But amazingly enough, it's a real product.
All right, last one here. All right, that was the last one. All right, so we can see that we have these 6 inflows, and the arrow shows you what direction it's pointing, and so fluid particles will, in this case, these fluid particles will come out of these holes and these inflows and impact this this flexible body here in the middle, the cloth. All right, so after you notice that those are set up correctly, so now we have to go into next here. So now we define the physical properties for each of those. And so we haven't yet defined what fluid, what type of fluid, what the properties are of the fluid, and we also haven't defined really what those bodies are at the top. So I'm going to go into this Manage Physical Properties, and I'm going to go ahead and click this Add button, add a fluid, and add again, and add a polygon. And so these are the properties that are available to be used in your model. So there's only 2 at the moment. There's polygon and fluid, and so I'll go ahead and click save. And so you can have multiple fluids that each have their own properties, and there's yeah, you can include multiple fluids in the same simulation. You can change the properties around. I guess I'll briefly show the types of things that you'll want to take a look at. So density, by default, it's something like water. So density, kinematic viscosity, and surface tension, and then also some heat transfer information. You can do non-Newtonian fluids as well. Yeah, we'll leave that for now. All right. So I want to change both of these walls to polygons, and I want to change the inflows to fluid. So if you had a second fluid in there, you'd have multiple options there that you could select from the properties that you defined previously. But basic idea is that you first define your properties, and then you associate them with the inflow in particular. All right, and then for each of these inflows, you can define how you want that to actually work. And so in our case, what we want to do is we want to change the inflow velocity, the emit velocity, to 1 meter per second. And we're going to do that for each of them. So 1, 1. Okay. All right, so then in this cloth FE body, we do want to do some things to make sure that it's being represented accurately, because it is such a thin body. We want to check a couple features. One is this double-sided DF, so that we want it to have contact from both directions, and are also going to specify a thickness of that sheet. So in this case, I'm just going to do 1 here. All right, so then ready to move on to the next step. And so if you click that next button, you're ready to change the particle size. So in this case, we're going to have a particle size of 0.01. So you'll set that for each model in particular. You'll have a single particle size, and go ahead and click next to go to the next step. Right now, gravity is set in the negative Z direction. We're going to go ahead and change that to the negative Y direction. We're going to go ahead and leave the pressure model at the implicit stabilized, but we will go ahead and include this viscosity calculation. Go ahead and include an implicit viscosity calculation. We'll leave the rest at default, but you can include surface tension models and turbulence models in that. All right, so we're not going to worry about heat transfer. And so now we're going to go ahead and set this initial DT. This is the time step that you'll want to be. This can take a little bit of trial and error and some learning how to use Particleworks to set this appropriately, but we can offer training on that if you if you get to this step and you're trying to get a model working, we can offer some specific training on how to get these parameters set appropriately. But go ahead and just decrease that by a factor of 10 for now. And this file output interval time tells you how often you're going to be saving information, saving animation steps as well. So rather than saving every 1/10 of a second, we're going to save every 100th of a second by changing that to 0.01. And so now this is ready to run, and so I'll go ahead and click execute. So actually all I'm interested in doing at the moment is going through the pre-process, and so I'll click on this pre-process option, click execute, and so it goes through that pre-process, and that completed successfully. And there's one more step there. So you can do this all in one step, but in this tutorial it's broken up into two, where you go into the simulation, and doing this will create some default files that are needed for the co-simulation. So you end up just selecting close without running simulation. So this will create the files that you need, but you don't actually need to run the simulation from Particleworks. So you click execute, and so that happens pretty instantaneously. And at this point, this this file is ready to go. I can click the save project, and I'm ready to close it or leave it open. As you run the simulation in RecurDyn, you'll simultaneously, it will simultaneously update both the RecurDyn model and the Particleworks model, so you can actually view the simulation while it's running in RecurDyn. You can view the simulation in Particleworks as well. And so, yeah, for this example, I'm not actually going to go through the entire simulation and have you wait here while I run the simulation, but that is the process that you'd go through. And so now from this point, all you'd do is you'd browse to where you opened up or where you saved that in the scene folder. You browse to your file that you created. And now in the external SPI file, you make sure that the connect is highlighted there. So if you turn the connect off, then it will run the simulation without connecting to Particleworks. And if you have the connect highlighted, then it's going to start try to search for a Particleworks file to co-simulate with. So make sure that the connect is highlighted there, and then from there, all you do is you set your parameters for the simulation, whatever you want your end time and step to be, and then you'd go ahead and click simulate. So I'm not going to actually go through and wait for this to complete. I do have this. There is also, I guess, just a YouTube video of this, and where you can actually walk through the process, and there's some information available online as well on the function-based support website about this tutorial in particular. But so yeah, that was the process there of how to get that simulation running. If you need more information about Particleworks, if you are unsure if your application is a good fit for it, we'd be happy to help you out with it, to get you started with co-simulation, work through some models with you, get you set up with the trial license or something like that. So feel free to contact me or Brant or Nelson about that, and we'd be happy to give you more information.